everybody. My name is Isaac Montoya, and I am the Director of Marketing here at Uptime Technologies. I would like to thank you all for joining us here today for week 3 of our 5th annual Airflow Management Awareness Month. I'll be joined here shortly by Mark Acton. He is an independent consultant and non-executive director at EchoSense. He'll be headlining today's webinar on International Data Center Standards. I'll also be joined by Lars Strong, Senior Engineer and Company Science Officer here at Uptime Technologies, who will be giving a brief introduction for today's presentation. Before I pass it off to Lars and Mark, I would like to quickly cover some of the housekeeping items. So everybody will be muted on the call just to take out any background noises, but we do encourage you to ask questions. And you can do so using the Q&A module that is located either at the bottom or the top of your screen. So please, throughout the presentation, please feel free to ask those questions, and we will have a Q&A portion at the end of the webinar, which we will ask those live and get those answered for you. If you happen to have any technical difficulties, please feel free to shoot me a message through the chat module, and I will try to get that resolved for you as quickly as possible. So, as I mentioned, this is week 3 of our annual Airflow Management Awareness Month. In week 1, Lars Strong spoke on airflow management best practices and cooling optimization. And then in week 2, which was last week, Bill Clayman, the Executive Vice President of Digital Solutions at Switch, discussed how to recruit and retain the next generation of data center professionals. If you happen to miss those presentations, they will be available on demand. And just let me know if you would like a link to view those, and I could shoot you one through the chat towards the end of this webinar. Next week, we'll be joined by Dean Boyle and Stu Redshaw, who are the co-founders of EchoSense. Dean and Stu bring many years of experience in data center optimization to this presentation, where they will be discussing how to identify the early warning signs of cooling issues with the help of AI and machine learning software tools. So if you haven't already registered for that session, feel free to let me know as well, and I will send a link through the chat box later in this presentation for you to do so. So without further ado, I'm going to pass this off to Lars Strong to get us started.
Thank you very much, Isaac. Well, I want to start by saying we're really excited to have Mark Acton joining us today to discuss this important topic. For those of you who don't know, Mark is a contributor to the Uptime Technologies blog, where he has spoken on emerging trends, data center efficiency, and the topic at hand, as well as data center standards. Mark and I go way back to early in our careers when we both worked for the Uptime Institute. So it is really nice to continue that history with Mark today. I'll tell you a little bit about Mark. He has over 25 years of experience in the data center industry and has been a specialist in the field of data center operations for over 20 years. He is concentrated on the delivery of business critical services for world-class data centers. This has included consultancy and technical advice, as well as senior management roles, where he has been responsible for service delivery in both strategic and operational management. Mark has extensive international experience covering data center facilities design and IT and facilities operational management. Mark is also a regular public speaker, conference host, and industry advisor on data center technical issues. He's currently acting as a consultant and non-executive director for leading data center operators and solutions developers, as well as being involved in international data center standards development. So clearly, Mark brings a wealth of knowledge to this very important topic. And on this topic, there's a fair amount of confusion in the data center industry about standards, certifications, and metrics. There's a couple of causes for this. One is depending on your business vertical and where you're located, how much you are required to follow standards and certifications will vary greatly. Also, there's a lack of cohesion among many of these standards, with some conflicting overlap. However, whether you're required to follow standards or not, there is a lot we can learn from the thought that has gone into developing them. The benefits of understanding and applying standards can result in improvements to efficiency, reliability, capacity, safety, and other areas. So really important to understand these. And as our industry grows and we become ever more relied upon, it's imperative to underpin our digital infrastructure with these well thought out, commonly agreed on global standards and metrics. Now, today, Mark will review what is available to you and provide a general understanding of the steps being made to truly standardize and globalize the data center standards landscape. So with that, I'll pass it off to Mark to get started.
Thanks very much, Lars, and thank you, Isaac, and thank you, Upsite, for giving me the opportunity to speak. Again, there will be questions at the opportunity for questions at the end, so do hold your questions and feel free to throw things at me when I get to the end of the session. So again, good morning to you, good afternoon to you, good evening to you, depending on which part of the world you're in. English accent. I'm based in London, so you know, I'm some way away from probably the majority of you, but nonetheless, you know, we're in a global world these days, and these standards that I'm going to talk about do apply globally. The idea is to really give you a run through, as you can see from the agenda on the screen now, those standards that we commonly use today in the data center world. The KPIs and metrics that are actually available from ISO IEC and probably are things that you currently reference and are aware of, but you may not necessarily know where they come from and what the true reference point actually is. Then we'll go on to European standards. And again, I appreciate this is probably a largely US audience, but you'll see why I'm doing it in this order as we go through it. Then we'll move on to the global standards, which are to a large degree somewhat in development. And then we'll move on to additional standards and references, followed finally by questions. So I hope that's fairly clear. I hope that gives you an opportunity to get a good grounding on standards and maybe a bit of a deeper appreciation of what they are, where they are, and how they're used. So moving in. So genuine standards really are important to us. They give us the ability to benchmark and reference. They give us the ability to benchmark and reference in terms of improving our operations, but also comparing and contrasting sites in different parts of the world, which is why it's so important that we have a framework which is genuinely global. And this is one of the reasons of the huge success of the Uptime tiers. You know, that was developed in 1992 or so. They were made available to everybody, and you know, as an industry, we've used those to a significant extent to allow us to have a common reference point and benchmarks. And we'll go on to Uptime in a second. However, do not confuse regulations and standards. Standards are voluntary. Regulations and legislation are not. The only time standards typically become required or part of legislation is when they're referred to by regulation. So for instance, you might have a standard that refers to electrical connections, electrical cabling or something of that nature. Typically that is a standard which is a reference point. When it becomes referred to in a regulation, that standard still remains voluntary. The regulation requires that that standard is applied. So there is a subtle difference between regulation and standards. Certification against standards is actually very, very confused and somewhat unregulated, much more than people realize. Certification is typically something that's done against a product. That might be a cable, it might be a device, and it's typically done in a lab by a set of fairly controlled, fairly well-controlled procedures and measuring techniques. Certifications typically do not necessarily apply to standards unless those standards have actually been written to be certified. Not every standard is, and that's the confusion that many people don't realize. Availability and uptime is probably the most important KPI for a data center. The reason we have data centers is ultimately to maintain continuity of service. That's why we spend a lot of money on data centers. Yes, we want that site to be as energy efficient as possible. Yes, we want it to be as cost effective as possible. But the reason we put our precious digital services into a data center is to retain that availability, to make sure those services continue to be highly available. Unfortunately, there is no agreed standard or KPI available to measure availability or uptime. You frequently hear references to percentage uptime, but actually it's a very, very flawed way of measuring data center uptime. Unless you are very, very clear what you're referencing, it doesn't necessarily work. And I'll probably address that in a later slide. Right, I am going to give you a quick run through of what's currently available. A somewhat confused landscape, and I will give you my view on the way things sit currently, and then we'll move on to what's available in addition and also coming down the pipeline at us. So as you'll see, we've got a plethora of different standards. Some are standards, some aren't. Some aren't even standards out there. Some are international, some are national only. So there's a good deal of confusion. I'm not going to dwell on this slide very long, but this is probably a simple representation of the many standards that are actually out there. So let's start with ASHRAE, American Society of Heating, Refrigerating and Air Conditioning Engineers. So to those of you in the US, this may not be something that you think about. However, to those of us working internationally, we often ask the question, why is a US standard important? Why is it, it's not a global standard, it is a US only standard. So why is it important? Well, it provides the environmental metrics that the IT manufacturers, the equipment manufacturers have actually agreed to and will warrant that their equipment works within. It also makes sure that by adhering to those environmental envelopes, which are actually published by ASHRAE, that the equipment is not damaged in any way by excessive temperature, humidity, or other factors. So it's very important in a data center context because we are hosting IT equipment. So we need to make sure that we are providing the appropriate environment for that equipment, that it continues to run properly, that it doesn't get too hot, switch itself off, get damaged, or be damaged by other factors, not just the environmental envelope. So ASHRAE is important in that context, and that's why it's used in the design and operation of data centers globally. But it is only a US standard. It is not a global standard. But it is a standard because it's referenced by ANSI, the American National Standards Institute. Last revised in 2015. Well, the TC 9.9 environmental envelope for data processing environments is what we typically refer to. And again, that was revised in late 2015. Uptime Institute, as I said earlier, Uptime Institute has been enormously, the Uptime tiers have been enormously successful. They have become a very, very common reference point. They might be considered a de facto standard in some respects, but they are not actually a true standard, despite the fact that Uptime refer to the tier topology standard. It is not a standard in the US, it's not a standard anywhere else, so it's not recognized by ANSI, for instance. But it's been an incredibly powerful and incredibly useful set of tools by which we have and continue to benchmark data centers. There is a certification program associated with the Uptime tiers. It is only run by Uptime though, so it's not something that can be generally applied by anybody. You basically got to go to Uptime, so it's a single source for the certification program. It's, again, has immense value and it's probably formed the basis of our entire industry in terms of standards and benchmarking. But it is not a true standard, so we need to be a little bit careful when we reference it as being a standard. We've also got TIA 942B is the current version. Immensely popular again, a lot of people know about it. It's been defined as essentially it is a telecommunications standard, telecommunication and cabling standard, which has historically also included data center elements. Originally, it had an appendix based on an agreement with the Uptime Institute, referencing the Uptime Institute tiers, which did lead to a certain amount of confusion between what Uptime were recommending and what TIA were recommending, because they were not necessarily the same things. So there was a degree of confusion there. The appendix has now been removed following a ruling in the US. So Uptime have required the term tier be removed from TIA 942 documents, and there's now reference to levels rather than tiers. The reason for that, I think, was down to competition around certifications, etc. So again, we're in a confused landscape. We're actually also in a somewhat competitive landscape when it comes to data center standards. So just be aware that these things do not necessarily work in sync, and there is a high degree of competition. I'm sure many of you have already seen that. So TIA 942 is actually primarily a cabling and telecom standard, not strictly speaking a data center standard, but it is used as a data center standard and a reference point. It is US only. It's not an international standard. It's only a US standard, although it is a standard because it is backed by ANSI. So again, the American National Standards Institute. However, one of the challenges is that it has been and still is somewhat US centric and somewhat prescriptive, and that particularly applies to the cabling and the telecoms elements. So not all of the elements within 942 can necessarily be applied across the globe because of some of the somewhat more prescriptive elements to that. So it cannot be fully adopted anywhere outside the US, and that's true in most cases, not all cases by any means, but it can be true in most cases. So if you're receiving a certification against 942, then there's probably an element of non-compliance because it's not possible due to local regulation. There are certifications being conducted or which have been endorsed by TIA. However, this does remain a little obscure. I believe there's only one company that's actually able to do this at the moment due to their relationship with TIA. Quite where that's going is open to some debate. The most recent update is revision B, again 942B, published in July 2017. I'm going to give you a quick rundown. There's always been, or historically, there's been a fair bit of confusion between the Uptime tiers and TIA 942. So firstly, neither 942 or Uptime represent international standards. TIA, as I've said, does have the backing of ANSI, but ANSI also support BICSI. So BICSI 002 is also an ANSI standard. So we have a little bit of confusion about what is, the US standard for data centers. Both claim that territory, but neither necessarily has it to their own. Uptime does have an official certification scheme, although it is only administered by Uptime. TIA does endorse a scheme which may lack a certain amount of independence. That remains a little obscure, as I've said. TIA is no longer permitted to use the term tier in their literature. So if you see references to TIA tiers, people have it not quite right, basically. TIA does mandate some level of utility power requirements. Uptime doesn't. So Uptime will only reference your generator, your standby generator capability, not the utility elements. It is perfectly possible to have a tier 4, an Uptime tier 4 certified data center without any utility power whatsoever. And a lot of people are confused by that. It is purely measuring generators. TIA is really a telecommunications standard and very heavily influenced by telecoms and cabling requirements. TIA, as I've said, is somewhat prescriptive and that it may not be able to be applied internationally. TIA does reference ASHRAE, which is useful. Uptime does not. And just be a little bit careful about the website TIA942.org. That's actually not administered by TIA. It's actually administered by somebody else. Again, I mentioned BICSI very briefly in passing. BICSI 002, it is, again, a standard that does apply to data centers or is applied to data centers. It's first published about 10 years ago, but it's not been particularly widely adopted, particularly internationally. It's not commonly applied. I don't come across it particularly often, but I think again for those companies and people that have more of a focus on the cabling and telecom side, they're more aware of it. The people who've got the BICSI RCDD, for instance, probably see this more often and come across it more often, but it's not particularly common in terms of a reference data center standard. BICSI also have an operational standard, BICSI 009. Both 009 and 002 were updated last year. So there is a very recent update in place. But the question, I guess, again, as I've already said, is because ANSI supports both 942, TIA 942 and BICSI 002, we are left to decide for ourselves which is the most appropriate for our particular environment or our particular business need. And there's an argument that there is, well, again, there is confusion over that, which should we be using, which is the correct standard, and the jury remains out somewhat on that, I'm afraid. As I've already said, there is competition between TIA 942 and Uptime for the data center space, the data center standards arena. So with that said, that's a brief run through of what we've actually got out there at the moment. It's not fully comprehensive. There are others out there. You can take your pick. There's, there are other standards used in Europe. There are other standards used in Asia. That is not comprehensive, but I think they're the main ones that we probably are aware of and reference in the industry. What I'm going to do now is go on to global KPIs and metrics, which are defined internationally, but these are standards in the sense, but they are standardized KPIs and metrics. So they are the things we use to measure and evaluate data centers. A lot of these things we actually commonly reference, but we don't necessarily know where they come from, as I said. So moving on. ISO, international and independent non-governmental membership organization and the world's largest developer of voluntary international standards. So you'll have heard of ISO, almost certainly. ISO 9000, ISO 9001, ISO 50000, ISO 27000. There are lots of ISOs out there, not just referencing data centers, but referencing all sorts of other elements of business practice, quality, energy management, environmental management, etc. We've all come across ISO in different ways. ISO works alongside the International Electrotechnical Commission, IEC, in the development of emerging international data center standards. Specifically, ISO IEC JCT1 SC39 Working Group 1, and I apologize for all the numbers, acronyms and whatever, but this is the arcane world of standards, I'm afraid. If you do need more information, the deck is available, or you can come to myself or the Upsite guys to find out exactly what these are all about. But this particular committee, Working Group 1, are responsible for development of the ISO IEC 30134 series of standardized KPIs and metrics. And these relate to data center resource efficiency, KPIs, key performance indicators. You'll also notice that there's an inconsistency of spelling of the word center throughout this deck. So clearly, being based in the UK and Europe, I use the center spelled CENTRE. The more international spelling, but of course there is also the more US spelling, which is the TER ending. I use center where appropriate in this because the titles of documents, both the ISO documents and the European documents, all use the international or UK version of center. So they are the correct document titles. I'm quite happy using either, but I am referring to the correct document title when I'm using the RE version. So just to highlight that it's not a spelling error, basically. So the 3134 series does include PUE. A lot of people still seem to feel that the Green Grid is responsible for PUE. That is no longer the case. The Green Grid developed PUE, but actually then innovated it across to ISO IEC, and it is now developed and defined by Working Group 1. And there is a standardized metric out there, which is referenced as ISO IEC 30134-2. Oops. So I'm not sure which, I think I may have hit, yeah, so I wasn't sure how many times I'd hit the key there. So this is a list of the standardized KPIs in the 30134 series. So we've got a part 1, the overview and general requirements. Part 2 is probably the one that people are most aware of in terms of knowing the name PUE. They may not know that PUE is actually defined by this document. It is no longer defined by the Green Grid document. So if you're referencing a Green Grid document, you're probably not referencing PUE anymore. You're referencing something else. So any proper measurement or reference to PUE should be made according to this document. Otherwise, again, it's something else entirely. We've also got one on renewable energy factor, REF. So that's the amount of renewable energy that you're actually taking into your site, that you're actually using. And then we go on to additional metrics, which again, people are very unfamiliar with and not really aware of. So we've actually got energy efficiency metrics for servers defined within this series. And we've also got equipment utilization levels for servers. So as we're all aware, it's important to measure server energy efficiency, but it's also important to measure how much those servers are being utilized. You know, typically across the data center estate, we'll see a fairly low level of utilization, from 0 in some cases, through up to, you know, maybe 20, 30, possibly 40% at the very maximum. But typically speaking, we don't really go much beyond that, even with virtualization. So it's a pretty useful metric that is relatively unknown and relatively poorly used. Then we have energy reuse factor, which is actually not a published standard yet. That's at the final stage of discussion. That should be released fairly shortly. And that's basically the amount of energy that you're able to reuse, typically in the form of so-called waste heat that comes out of your center, and you can possibly use in some manner or other. Obviously, various alternatives available there. And then we go down into a couple of other metrics that you may have come across, which again are still in discussion, still under development, but should be released very shortly. I think we're in the final stages there. So carbon usage effectiveness, water usage effectiveness, and these relate to, as you might imagine, to the power usage effectiveness that we talked about earlier. So it's, you know, it's the how much overhead is a building providing in terms of its carbon output or its use of water. How much of those resources are we actually consuming and or putting into the environment? So similar to the way we use PUE, but not the same as, obviously. And just to reiterate a previous comment, PUE is now properly defined as ISO IEC 30134-2. If you're not using that, you're basically not referencing PUE. So anything that you're reporting, measuring, doing whatever with, basically, again, if you're not referencing that document, you're doing something else entirely. The important thing to realize about PUE, not only is that the way it's defined, but it's not an energy efficiency metric. And it does sort of frustrate me continually that people refer to PUE as an energy efficiency metric. It's not. Never has been, never will be. So possibly one for questions later, and do feel free to challenge me on that if you feel it's appropriate. But PUE is not an energy efficiency metric. So one of the things about these standardized metrics is that they are often used, but not necessarily always appreciated where they've come from and what the true reference point is. They are considered useful, they are routinely referenced, but some of them are probably less commonly known, less well used, and I think it's probably appropriate that people are aware that they exist and possibly start to use them, particularly when we start talking about the IT estate. You know, we continue to look at what the way a building might be performing and the building infrastructure, but I think we're less good at looking at the way the IT infrastructure performs. And some of these metrics and KPIs actually start to allow us to be able to do that, which I think is probably a very good thing. Generally, the awareness of the 30134 series is pretty poor. I routinely talk to people who aren't aware that it exists, that it's out there, it's published, it's extant, and people should probably be using it. And as a result of that, I do see relatively regular attempts to reinvent the wheel. I saw someone published recently, well, late last year, a paper that suggested that water usage effectiveness would be a good metric, not realizing that actually ISO IEC have actually been working on it for 2 years. So again, we do get regular efforts to reinvent the wheel that you know, probably don't really help. Worth noting again that none of these measures are direct measures of overall data center energy efficiency. We're still missing that. Data center, going to the final bullet, energy efficiency needs to, from a pure physics perspective, needs to reference useful work done. At the moment, we have no way of measuring the useful work done in a data center. There are lots of proxies that we might be able to use, but there is no way of measuring the useful work done. You know, if you think about it in a very, very pure sense, you know, what are we doing in a data center? Well, we're sort of ordering electrons or converting electrons to photons and back again. How do we define that as useful work done? Very, very difficult, and which is why we still do not have an energy metric for a data center as an entity, as a whole. And I still think we've got some way to go on that. The other one that's still missing is availability, as I've said. There is actually work underway to try and better measure and reference availability. It's actually being done in Germany, and it will be adopted as part of this series when it's done, but it's very, very early days yet. And the reason the nines don't work is that 6 nines by SLA still allow for 32 seconds, approximately, somewhere between 31 and 32 seconds of downtime per year, which you might think is not great. 32 seconds power outage in a data center is going to leave you, completely stranded for several hours and possibly days. But it does get slightly worse than that. So not only can we get 32 seconds of downtime per year by SLA, so we'll still be within SLA, we could have 32 1-second outages, or 64 half-second outages, 128 quarter-second outages, each of which will have exactly the same impact. It'll take down the entire IT estate. So, stating 6 nines is meaningless unless there's a very, very explicit reference to what we're talking about by 6 nines. Is it packet loss? Is it energy? Is it cooling? Is it service availability? Unless that's defined, it's a kind of meaningless metric. Just quoting 99% or more uptime is kind of pointless, really. It doesn't mean anything. So we do need something better, and we don't have anything at the moment. We will hopefully have something in the not too distant future. There are additional standards, standardized KPIs out there. I'm not going to read through the list. You can do that for yourselves. So what I've given you is not exhaustive, but I do think that 30134 series is the most important and really the most commonly referenced, even if people don't necessarily know what they're referencing. This one is merely here for your reference going forward. European standards. As I said, there is a reason for me referencing the European standards. I'll go on to it fairly quickly. You'll see the reason as we move through this. So CENELEC is a European standards body appointed by the European Commission. Works alongside CEN, which is the European Committee for Standardization. The important takeaway on this slide is that there is a technical committee, TC215 Working Group 3. And again, I do apologize for the arcane nature of these standards bodies. Nevertheless, they are responsible for the EN 5600 series. CENELEC are actually also a member of a coordination group across Europe and across the European Commission, which ensures that we are standardizing any standards, not just data center standards, but standardizing any standards that come out across Europe. So we're trying to avoid that sort of competitive element and somewhat confusion element that you might see in other parts of the world. But moving on onto what 5600 actually looks like and means. So in 5600, it specifically addresses data center facilities and infrastructures. In fact, that is the title of the document, what I put up there in the parentheses. It is being essentially drafted and commented on, agreed by comment and consensus, as genuine standards are, by the national standards bodies that actually fit into the ISO organizations. So they are the ISO representative bodies appointed by national government normally. These bodies are again contributing and commenting on the EN 5600 series of standards. So for instance, in the UK, that would be BSI, which is the British Standards Institute. That would be totally analogous to the to ANSI, the American National Standards Institute. So similar body, different nation. So as I've said, TC215 Working Group 3 is responsible for the EN 5600 series. The series includes, as you might imagine for a data center standard on facilities and infrastructure, includes building, construction, power, distribution, environmental control, and for environmental control, read cooling, telecoms and cabling, security systems, management and operations. The important thing to take away, and I'll go into this in a lot more detail later, is that this standard, this European standard, has now been adopted by ISO as the basis for an international standard. We'll come on to that in a little while. So this is what the EN 5600 standard looks like. Again, you've got an introduction, just rather very, very similar to the 3134 series. So there's a part one, there's an introduction that tells you what's in the standard and how it should be applied and how it should be used. We've then got individual sections or documents on building construction, power distribution, environmental control, as I said, which is cooling. We've got cabling, so it says telecommunications, but for that read telecoms, data, fiber, copper, everything. Physical security, management and operations. Of those documents, the management and operations is probably the one that needs the most work, but everything else is published, it's extant, and generally speaking, in at least its second revision. So, you know, this is becoming a mature standard. What you'll also notice in the section 4 of the standard, so 4.1 to 4.5, are actually the KPIs that you saw earlier. So as you, the way the standards typically work is that rather than reinventing the wheel, as I said earlier, what they'll do is reference other documents. So this standard references those standardized KPIs that are already published. So all they really do is they take that standard, that ISO standard, and they incorporate it into another standard. It's the same document, just has a different header. It's exactly the same deal. It just forms the basis of a broader standard series. And this is the way the standards tend to work in the international community. Rather than reinventing the wheel each time, you will reference a standard. So if you're talking about quality management, for instance, within the EN 5600 series, you reference ISO 9000. You don't reinvent it, you don't republish it, you don't rewrite it. You basically incorporate it and reference it, and which is one of the reasons that standards do work, on the basis that individually they may be updated. You don't have to update the entire standard, but you are continually up to date with the latest revision of the latest standard in whatever area you're actually referencing. And then we've got some additional areas down at the bottom in addition to those KPIs. We've got the data center maturity model, which you may have heard of originally, again, from the Green Grid. The Green Grid have actually novated this across to the European Standards Organization, to CENELEC, and asked them to continue its development because it's stored within the Green Grid. So the maturity model is now being developed in Europe, not by ISO in this case, actually in Europe, to be something that will be published as part of this standard. We've also got, and that's actually going to be a technical specification, a TS, rather than a true standard. EN stands for European normative, so that's a true standard. The TS is technical specification, so it's actually not a true standard. It's a reference to a standard. And then we've got what we call technical reports, which sit at the bottom. There are two technical reports here which reference practices. So one is on energy management and one is on environmental sustainability. And then finally, we've got a 99-3 document, which is about the application of the EN 5600 series. That's how to use it. And that addresses the thorny topic of certification. What it basically says is that you can use this series of standards, these documents, to issue a letter of conformity, but you cannot necessarily issue a certification. And there is some degree of semantics involved in that, but officially that is the stance. Global standards, ISO IEC, and you'll see at this stage where I'm going to with the European basis. And do remember that there are questions at the end of this. So if you feel like there are things I've said that you want to find a bit more information on, or challenge, or discuss at length, then do hold your questions till the end, and you'll have the opportunity to bring them out. So this really is a game changer. So EN 5600, the European standard, has been adopted by ISO IEC as the basis for something called TS, so Technical Specification 22237. This is a published document by ISO. This is something that's out there. You can buy it now. You can go to ISO, you can pick it up, you can buy it, you can reference it. But all you're actually doing at the moment is you're buying a copy of the EN 5600 document. It is literally identical. It's not yet a full standard. However, it is being revised by international comment and consensus. So basically the international ISO committees are sitting on a regular basis to comment these documents, to make sure that they are applicable internationally in any region, in any country. They can be used by any party. That is, again, done by any of the members of ISO. Yeah, anybody who is any national body that's a member of ISO can participate in this debate and this development. The US are certainly very heavily involved. ANSI very heavily involved. In fact, the committee chairs on both Working Group 1 and Working Group 3 are both from the US. So, you know, heavy involvement from the US side. This is something that is very, very much in development and is, again, a game changer. Not yet a full standard, but very much watch this space. The full standard will retain, though, the concept of availability classes. So availability classes is something that's core to EN 5600. So availability class, if you were to think of the levels in TIA or the tiers in Uptime, you'd be in about the same or the right area in terms of availability classes for both EN 5600 and TS 22237. So there are 4, they are defined in different ways. They look very similar, but the definitions are actually a little different. So not quite the same approach. There is something of a distillation of approaches from other areas, but the approach is different. Nonetheless, if you think of availability classes as, you know, tiers, levels, whatever else you might have seen out there, you'd be pretty much in the right sort of ballpark, and that will continue in 22237. That's already been adopted in what will become the standard in the draft documents, which are not that far from publication now. So what does it actually look like? What does 22237 actually look like? Well, this is it. This is what's currently available. As you can see, it directly reflects elements of the EN 5600 series. Not all of it, not all of it's been adopted, but the key elements. So again, you've got the concepts, the building construction, power, environmental stroke cooling, telecoms, stroke datacomms, cabling of any description, security and management and operations. You know, it's all there. It's the first sections of the 5600 series. Again, not yet published as a standard. However, pretty close to being published as a standard. I think had we not had the current pandemic, I think we'd have certainly been seeing these documents published, some of these documents, not all of them, being published this year. It may still happen towards the back end of this year, but probably unlikely now. But certainly, I think you're going to see these documents emerging as a full standard next year. Not all, some. So this is a game changer. It's an ISO standard. We use ISO 9000, we use ISO 27000, we use 50,000, we use 14,000. This is the coming data center standard. So it's well worth being aware of. And as I say at the bottom there, over time, it is certain that data centers will be referencing this as a global benchmark, a global reference. Now, whether that's for engineering purposes, for comparison purposes, or simply marketing purposes, who knows? And to be honest, it doesn't really matter, but people will be using it in those contexts straight away. There's a few additional standards. I'm going to run through very, very quickly in the interest of time. The list I put together regarding the 5600 or the 30134 series, etc. They're the main ones, but there are other standards that we do reference fairly regularly. And I'm going to run through those very quickly, and then we'll have a time for a Q&A session. So, European Code of Conduct, and again, I appreciate this is probably a largely US audience, but nonetheless, I'm going to reference this because it does go on to be referenced elsewhere. This is a series of best practices that has been put together over 10 years or so, routinely updated every year. It's published and endorsed by the European government or the European Commission. Notwithstanding that Britain obviously have chosen to leave that, we will still continue to be involved in helping to develop this. The last revision was released in January this year. It is an update. And I think the important thing to realize on this is that it forms the basis of the best practices documents that I mentioned in the EN 5600 series, which may over time ultimately be referenced in the 22237 series. That hasn't been officially agreed yet, but that's the way these things tend to go. We'll see how that actually happens. So the two documents that the Code of Conduct has been incorporated into are the technical reports that I mentioned earlier, 99-1, 99-2. 99-1 is the energy management best practices. 99-2 is environmental management. Obviously related topics, but not the same. The difference is that the TRs will be available in multiple languages in addition to English. Currently, the Code of Conduct, despite being a European document, is only available in English. So the advantage is that the technical reports as part of the 5600 series will be available in more than one language. And that may be relevant for people in, different parts of maybe North or South America in particular, where you might have Spanish or French speakers who would find it more accessible in those languages. LEED and BREEAM, basically building assessment methods, looking at the environmental impact of building. LEED is very much a US-based assessment method and certification method. Less common in Europe, popular in the US, popular in some parts of the world. Not particularly, does exist in Europe for sure, but is not particularly well adopted in Europe. The one thing about LEED is it's not specific to data centers; it's very generic, but it has been used as to certify data centers. The competing, I won't call it a standard because it's not a standard, but assessment method is something called BREEAM, which is a building research establishment assessment method, which is UK based rather than US based. Very similar. Very similar things. They seek to achieve the same thing. The difference really with the BREEAM assessment method is that it does incorporate some data center specific elements, and it was actually updated very recently, actually late 2019. Probably more widely used globally than LEED, generally, not necessarily within the data center industry, admittedly, but generally speaking, and is somewhat more European in approach. LEED probably is more common in the data center industry generally than BREEAM, but that's specific to our particular industry or sector. There is another European set of telecommunication standards, which again, you might consider possibly a little more analogous to TIA in the sense that these are determined or focused very much on the telecommunications sector. They do overlap with some elements of data center. So, what's a small data center versus a telecoms POP? How do we define the difference? There's clearly a degree of overlap between those two areas. So there is inevitably some overlap. Hence the reason for having a coordination group across Europe, which tries to make sure that we're not reinventing wheels or treading on anybody's toes. So that's a useful exercise. But you may see actually standards out there. They're different to other standards. They're actually free to download, and so they are probably used simply because they're free. So that's a possibility where you may come across them. ISO 50000 energy management, regularly applied to data centers, particularly in Europe, possibly less so in North America. But again, very commonly applied to data centers in Europe. As I said earlier, one of the things about standards is that they are very, all standards authors and documents are very keen to make sure they dovetail with other standards. So 50001 particularly does work very well with ISO 9001 and 14001. ISO 9001 being quality management, 14001 being environmental management. People do use, probably in Europe, 50001 more commonly because there are some legislations where having a certification, and 50001 is a certifiable standard and written to be, as are 9001 and 14001. Having a certificate for compliance with 50001 does potentially give some carbon tax relief. So basically gives an allowance in some areas for basically reduces the penalty for carbon output in some cases. So it can be quite useful in that sense, which is probably why it's been taken up in Europe more than other parts of the world. 14,000, again, environmental management systems. does work very much in addition to kind of LEED and BREEAM, which assess building design and construction. But this again is relating entirely to environmental management, environmental impact, as opposed to the 50,000, which is energy management and use of energy. This is another standard that you probably see relatively commonly in Europe, probably less commonly than 50,000, but still relatively common. Certainly less common than 9,000, but it's something that you will see out there. 1440, so something that I think is becoming of increasing focus is lifecycle management, particularly in the data center world, where a building might have a life expectancy of, let's say, 30 years. Within that 30-year period, you might expect to see a major infrastructure refresh after 15 years. So the useful life expectancy of a lot of infrastructure might be around 15 years. So that whole life cycle element, the disposal of infrastructure, but also, frankly, the planning, the budgeting, the awareness that these things are going to be happening and will have an impact, and increasingly disposal of these elements becomes increasingly challenging. So it's probably something that is useful to be aware of and reference increasingly. Not something that is relatively common in the data center world, even in Europe, but I think it's something that will be of increasing focus as we move forward. So final slide before we go into questions. This list is absolutely not exhaustive. There are an awful lot of other data center references, national standards, and claims to be standards out there. I haven't even gone into what's happening in Asia. There are things in Germany as well. So there's a lot out there that I could reference, but obviously simply on the basis of time, I cannot possibly hope to get everything in there. So I apologize if I've missed out your favorite standard. Do be aware that certification is not necessarily as simple as it might at first appear. Not all standards are certifiable. Only standards that have been written to be certifiable can actually be certified. What you normally get with a standard, and this is true of any standard anywhere, is what you normally get is something called a letter of conformance or a letter of compliance. So as you could, for instance, go and choose your favorite MEP firm, design consultancy, and say, could you give me a certificate against, say, for instance, TIA 942 or EN 5600, something of that nature? And they'll say, yes, we'll be happy to do so. And they'll give you something. They'll take the document, they'll look through it, they'll check your site and make sure that you are ticking all the boxes. And they'll issue what they might call a certificate. It's almost certainly not a certificate. It's a letter of conformance. Not necessarily a bad thing, but it's not a certificate. It's something else entirely. Again, how useful that might be is entirely what your intended purpose is, and I'll leave that one up to you. And to highlight that, this is actually a pretty poorly regulated area with very little formal governance. So just be a little bit careful about what you're actually buying and who you're going to buy that thing. Finally, make sure the standards that you're actually applying are appropriate for the business. It may just be marketing value. It may not be engineering at all. It may not be technology. It may just be marketing, which is fine, as long as you realize where you're going into this and what you're paying for and what you're actually ultimately going to get out of it. And so with that, I'll sign off by saying that caveat emptor, the famous Latin phrase, does actually still apply in our industry. Just be careful, what you buy. So buyer beware. Remains a sensible approach. And that is it. Thank you very much for your time and attendance. I think we're on to the questions.
All right, great job, Mark. We've got a ton of questions coming through, so we're going to try to get through all of them. Yeah, we're going to try to get through all of them. If we don't happen to get your question, we will follow up with you after the webinar. So let's jump to the first one. Is there any standard for a server or router manufacturer to follow for airflow direction guidelines, i.e. air inlet from front, air outlet from back, etc.?
Simply put, no. We clearly have the ASHRAE environmental envelopes, which define what we should be taking in at the front, what's expected and what keeps us within warranty. But no, there is no, certainly not that I'm aware of, there's no formal standard that says you have to, as a server manufacturer, you have to take in air from the front, expel it at the back. We've all had problems with, I think, particularly in network devices where cable comes in all sorts of strange directions. The air is taken in from the back, the front, the side, or whatever, and exhausted from the top, the bottom, the side. So yeah, we've all experienced those problems. And to my knowledge, there's absolutely no standard. No, I'm afraid not. If only life were that simple.
All right, thanks, Mark. Moving on to the next one. So you had quite a few standards in here, Mark, some relating to telecom, some relating to data centers. So this question is in regards to the differences. Can you explain the differences between cabling, telecoms, and data centers?
Yeah, so cabling, okay. Well, there are cabling standards out there which refer to different types of cables and how those cables perform. Interestingly, many of those are actually certifiable because they are products that can be measured and therefore certified to perform within very specific tolerances. So there are cabling standards. There are references to how we should be using different cables. There are fire regulations which tell us what kind of cables we can use in certain situations and how those cables should perform in terms of their fire ratings, etc., which is obviously pretty important and may, in fact, will almost certainly be part of local regulation and legislation. So when we come to telecoms and datacomms, it's a little bit more confusing. There is no real difference. Telecoms historically was voice, and datacomms historically was data, but those two are pretty interchangeable now. So I don't think we care to differentiate. It's a term. The reason it's used in both the current 5600 standard and the emerging 22237 standard is probably more historic, rather than saying that specifically we're talking about telecoms rather than datacomms. I would suggest that it's a coverall in exactly the same way that we talk about environmental elements when actually we mean cooling. So I wouldn't read too much into the fact that we're actually referencing telecoms and cabling. It is really the cabling, the use of cabling, how cabling should be, what kind of cabling should be put in, how that cabling should be perform is really what we're talking about. Telecoms versus data centers. Yeah, I mean, again, what's a telecom site versus a datacom site? If you're talking about a small edge style deployment, how does that differ from, a telecoms point of presence? I think increasingly there's very little difference. Certainly if you look at things like cable landing stations these days, a lot of the equipment is no longer DC, it's often AC. So what we traditionally think of as telecoms equipment is probably no longer so differentiated from what we'll see in a typical data center. I hope that answers the question.
All right, thank you, Mark. Let's move on to the next one. Has there been any certification efforts against BICSI-002?
There is no, as far as I'm aware, and 002 is probably the standard that I am least familiar with, in all honesty. I've not spent a lot of time looking at it or working with it because it's not particularly commonly applied, frankly. There are almost certainly certification efforts. Whether they are true certification efforts, I'm not sure. I suspect that BICSI will have a program of some description that will have some elements of certification or issuing of letters of conformance. Quite how that's administered and how it works, I'm afraid I don't know. That's something I'm afraid would have to be followed up with BICSI directly. So I apologize, I can't answer that one.
Okay, let's move on to the next one. What are the implications when a site is being reviewed against both TIA 942 for design and UTI for operations? Where are the potential areas where they cannot be harmonized? Appreciate your kind advice on this.
Yeah, as I said, the main one, I mean, there are a few areas. So, for instance, TIA will go into sort of cabling specs and that sort of thing, whether it's power or data cabling. Uptime doesn't. The way I would think of uptime is that uptime is more of a design philosophy in many respects. So what you won't find from uptime is a detailed document that tells you exactly how you would achieve, let's say tier 3 or tier 4. You'll give them some broad guidelines, but there's no detail requirement. TIA, on the other hand, is a very, very comprehensive document that gives you all the detail you can possibly want, and possibly a lot more, actually. So in that respect, they're very different. They approach from different directions. TIA, you can basically get a letter of conformance, a letter of compliance, from any good engineering consultancy on TIA. You cannot you can't get the same thing on Uptime. You've got to go to Uptime to get any certification. So it's a bit of a closed shop in that respect. There is a formal certification program now endorsed by TIA, but I think there's only one company that can offer it, and so whether it's truly open or not is open to a degree of debate. But that is out there. In terms of the detail, I've mentioned the cabling, so that's fairly prescriptive on the TIA side. Uptime don't reference it. The one area of difference that I'm aware of is on utility power. So TIA will talk about utility power and requirements around utility power. So, the kind of connections you've got, how many there are, et cetera, et cetera. Uptime actually don't reference utility power at all. And it's a really big area of confusion, or has been historically. So Uptime don't care whether you've got utility power or not, because all they measure you on is actually your generator capacity. And whether your generators fit the requirement. Their view is that you can control your generators, you own them, you control them, you maintain them. You cannot control the utility. If someone somewhere downstream in the utility decides to switch it off, then it goes off. You have no control over it. Or if demand goes somewhere else because it's more important than you are, then again you get switched off. The way they describe it is that utility is an economic alternative, but actually your primary power is actually your generator, or your generator sets. So that's probably the biggest difference you're going to see, other than the level of detail that you're actually given access to by the different parties. Uptime, relatively little, TIA, quite a lot. Hope that gives you information. There are more differences though, but to be explored.
All right, thank you, Mark. And I think we got time for just one more here. Where can we download the N5600 standard? Maybe this is true maybe for all these standards, Mark. Where can people download these?
Yeah, good question. So the ISO standards, just Google ISO. If you type in ISO 22237, it pretty much takes you straight to the ISO sites, and you'll find there's a number of documents that you can buy. Again, just be aware that if you're buying the 22237 document, it's not yet the fully published standard. It's only a technical specification rather than a true standard. In all honesty, again, it's identical to the published EN5600 documents. Similarly, if you go to your favorite national standards body, so for me, it would be the BSI in the UK. You can go to that website, and they will have all the documents that are recognized by your national standards body. So I can download the EN5600 as what's called a BS-EN. So it's a British standard European normative. So I can download that from a BSI site. I can go to any national site and download it. I have to pay for it to do that, as with most standards. But if you if you Google your national standards body, whichever region you're in, and EN5600, then you'll basically get reference to it. The advantage of doing that if your national standards body is that you'll get it in your local language, which is obviously an advantage. And if anybody wants it in English, I would suggest going to the Irish National Standards website to download EN5600 from there, because it's cheaper than the English one or the British one. Top tip: it's same document exactly, just slightly different name.
All right, thank you, Mark.
I shouldn't be saying that. I'm doing my home standards body out of money here, aren't I? I'll be shot.
All right, thank you, Mark. Really appreciate your time here, and thank you everybody who joined us. Thank you for all the great questions. If we weren't able to get to yours, we'll follow up with you after the webinar. We will also be sending out a recording and PDF slides after the webinar for you to watch us and go through at your leisure. So once again, Mark, thank you so much. It was great having you. We really appreciate you joining us here today.
Thank you, Isaac. Thank you, Upsite, and thank you everybody for joining. Thank you very much.